All right, guys, let's talk about lesson 10.3. The title of 10.3 is Mean Absolute Deviation. So there's kind of two parts to this, mean and then absolute deviation. Now, the word deviation, let's think about deviate. And that's really just like how much a quantity sort of strays. You know, when you deviate from the road, you stray off of the road. So when we think about absolute deviation, it's an interesting measurement. And I think the best way for us to talk about mean absolute deviation is just to make up a set of data. So here we go. I'm going to give you a set of data. Let's pretend this is the number of pairs of shoes you have in your closet. Maybe somebody has 8 pairs, 4, 7, and maybe we got somebody out there who has 12 pairs of shoes. So this is just a small set of data. To figure out the mean absolute deviation, the first thing we need to figure out is what the mean is. So the mean, again, is you just have to add up the terms. So 8 plus 4 plus 7 plus 12, right? So we just have to add up our terms. So that's 12. 12 plus 7 is 19, and 19 plus 12 is really 20 plus 11. So that is 31. And 31 divided by 4, because that's how many there are, this ends up equaling 7.75. That's our mean. Now, to figure out the absolute deviation, we've got to figure out how much does each data point stray, deviate from the mean. That's what we're looking at here. How much does each data point deviate from the mean? All right, so absolute value just means it doesn't really matter which one you subtract. I can do absolute value of 8 minus 7.75. And I can get an answer there. And I can do the absolute value of 4 minus 7.75. Notice I'm just going to keep subtracting the mean. That's the 7.75 that I keep subtracting. And then I'm going to do absolute value of 7 minus 7.75. That's going to give me a number. And I'm going to do it one more time because I have 1, 2, 3, 4 different data sets. 1, 2, 3, 4. And so then the last one I'm going to do is 12 minus 7.75. And the absolute value says it just doesn't matter if it's positive or negative, right? So if we do 8 minus 7.75, right, that's going to give us 0.25. That's how much this data point deviates from the mean, 0.25. And then we have the next one. Well, the absolute value of that deviation is 3.75. Well, and this is an easy one for us to figure out. That's 0.75. And then we have this one up here is 4.25. So each one of these absolute deviations is talking about the amount of distance. This is the amount of distance of each point from the mean. And what we need to figure out now is the mean of the deviation. Well, okay, that's easy enough. We just have to add them up and divide by how many? So we have 0.25 plus 3.75 plus 0.75 plus 4.25. Man, these numbers are actually easy for us to group, right? If you think about that, I hope you're seeing this right now. If I put these guys together, well, that's equal to 1. And then if I think about this differently, I can put these guys together. Well, because the 0.75 and the 0.25, that is equal to 8. So all together, the sum equals 1 plus 8 equals 9, and then I have to do 9 divided by 4, and that is 2.25. This value is the mean absolute deviation. And what does it mean? It means on average, each data point is about, I'm saying about because we had to round it, is about 2.25 units away from the mean. And that's all there is to it.